Hello there guys, in this video I'm going to explain to you about the chemistry paper 4 May-June 2017 and it's a 43. The duration for this paper is 1 hour and 15 minutes. Okay, without wasting any time, so let us move to first question. Okay, here we have the first question. 6 different atoms can be represented as follows. Okay, now we have a D, E, G, J and L. Okay, so not forgetting here, the highest number that we have here is nucleon number. Okay, or in otherwise we call it as a mass number. Okay, it's a mass number. Okay, the down one here. Okay, so this is, we call it as a proton number, or in other words we also call it as a atomic number. Okay, now answer the following questions using atoms from the list. Each atom may be used once, more than once, or not at all. Select one atom from the 6 shown which has exactly 7 protons. Exactly 7 protons. So as I explained here, the number at down. And okay, now we have 2, 1, 2, 6, 6, 7, 9. So the answer for the first one is J. Okay, A2 has exactly 6 neutrons. So how do we find the answer for neutron? Now we have a nucleon on top and we have a proton. Okay, over here. So to find this neutron, we have to minus. We have to take the nucleon number which is on top minus the proton number. That's how we got this neutron. Okay, the NO neutron. Okay, so when we minus this, the neutron we are getting here's 2, here's 1, here's 6, here's 7, here's 7, and here's about 10. So exactly 6 neutron. So here will be E. Okay, this is your answer. Okay, number 3 has more proton than neutron. Has more proton than neutron. So we just have to compare the proton and the neutron, the numbers. More proton. So you can see this one, the D. Okay, the only D, the D atom here, we have proton 2 and neutron as 1. And when you compare with A, E, G, J and L, they have more neutron. So your answer here will be D. Okay, has a electronic structure 2,5. Okay, electronic structure we have to look at is proton number. So for atomic state, the proton number will be equals to a electron number. So if it's 27, the total here should be, sorry, it's 25. So the total here should be 7, right? So 7, so we just have to look at the proton number which has 7. So here you have only one answer, which is the J. Okay, so let us scroll down. Okay, it's an atom of element from group, this is 7. Okay, group 7 of the periodic table. So this is 5, 6 and 7. So group 7 we have to look at their electron arrangement, which has 2.7. The last here we call it as a valence electron. So this is the one will show that the group is 7. Okay, the 17th group. So now let us check the atom which has the valence electron of 7. So now we have here 2.5. No, this is 2.4. This group 14. This one is 2.4. Group 14 2. This is 2. This one is 1. So it's group 1, group 2 or helium, and might be this one. Okay, the L, which is 9. So you can break it into 2.7. So this is the electron arrangement. So your best answer here will be L. Okay, so let me scroll down over here and you can see this one is the answer here is L. Okay, it's an atom of a noble gas. Noble gas means it must be stable which has helium. Helium has about 2, and the other gases here will end up at 8, their valence electron. Okay, like a 2.8, 2.8.8. So we have to search for 2 or either 8. So now let us look at the atoms. So here the only choice, here we have, this is 1, is not stable. This is 2.4, not stable, not stable, not stable, not stable. So your only choice is here, okay, 2. So your answer here will be atom D. Okay, so here I just write it down as a atom D. Okay, so I hope you can understand this. Okay, now we are going to the B. Okay, now 2 of the 6 atoms shown are isotopes of each and either. So what is isotopes? So isotopes, you just have to remember like 2 examples, like carbon 12 and carbon 13. So here will be like 12C6, and here also will be 13C and 6. As you can see here, the proton number is the same. Okay, so proton number is the same. So what is isotope? So just remember these 2 examples. So you can say same proton number, and let us compare the nucleon. Alright, and then they will have a different nucleon number or mass number, different nucleon number, or you can also say different in neutron number. Okay, different in a neutron number. So that is what's the mean by isotopes. Now, which 2 of 6 atoms shown are isotopes of each other? So I think we have found which has the same proton. Okay, so here, which one has the same proton? So we have E, alright, so we have E here, which is 12, 6 and 13G. So 6 and 6. So it should be E and G, alright, so E and G. So we just write it down here, is E and G. Okay. Why do isotopes have identical chemical properties? So when they are having a same proton number, alright, when they are having a same proton number, obviously they are from the same group. So they have a same electron arrangement too. So you can say they have a same electron arrangement, or you can say a same number of electrons. Okay, so they have a same electron arrangement in their same electron arrangement and valence electron. You can add on here valence electron in their outer shell. Okay, in the outer shell. So okay, I hope you can understand this. So the total marks for this one will be about 10 marks. Okay, so let us move to the second question here. Okay, now we have here cyclopropane is a colorless gas. Cyclopropane reacts with bromine at room temperature. Okay, this is supposed to be a brown color. Alright, so when they breaks up into this bromine, so this one will become colorless. So you can expect a question in that way. The chemical equation for the reaction is shown. So cyclo means they will build in a circle. So let's say we have a cyclobutane. So you will have this cyclobutane. So this all is close together. So they will have this closed cycle. So you can see that. Okay, this is a cyclo. Okay, what is empirical formula of a cyclopropane? So let us calculate the whole thing. So here will be, let me erase the stuffs off. Okay, so here we have a C3 and H is 1, 2, 3, 4, 5 and 6. So we can simplify this, you will get CH2. So that is your empirical formula. It means the simplest form of a formula. Okay, so here, what color change, if any, would you see if cyclopropane is bubbled with aqueous bromine? Okay, so here will be like, you can say there's a few colors here. We can say brownish color, or we can also say it's an orange color. Okay, and then it will change to colorless. Okay, it's a colorless solution here. Okay, now let us move on with the next one. Okay, complete the cyclopropane with, okay, the reaction of cyclopropane with bromine is exothermic. Exothermic means they releases heat. Okay, they releases the heat energy to the surrounding. So the energy will eventually drop. So here, complete the energy level diagram for this reaction by adding product. So you can see here. Okay, so normally like here we have a cyclopropane and bromine, right? So the graph will be going up first, and then will be going down. Okay, will be going down. So at this part here, and what's the name of the product? The product is a dibromopropane. Okay, so we just have to write down here the names. Dibromopropane. Okay, so this dibromopropane, and not to forget, here we will have an activation energy. Okay, this is an activation energy. Okay, this is the activation energy, and then the energy loss will be here, from here to here. So this is the energy that are lost, releases heat. All right. So if you have an endothermic graph, your endothermic graph should be going up and stays high. So this is endo, and this one is exo. Okay, so this is like a revision here, and we have successfully added the energy change. So I should put here H. Some question will ask us to put the E. Okay, so I hope you can understand this. We'll move on with the next question. Okay, so for this question is a calculation of this endothermic and isothermic. Okay, propane are also react with bromine. Okay, over here. Use energy bonds in the table to calculate the energy change. Okay, so now to break the bonding, to break bonds, you need to absorb the heat. Okay, you need to absorb the heat. So if you absorb the heat, you will classify it as an endo. This one is forming the bond. Forming bond. So when you're forming the bond, you will release this heat. When you release heat, what happens here? You will have exo. So now we have to calculate based on each part here. Okay, now let us calculate for CH. Okay, how many pairs we do have? 1, 2, 3, 4, 5, and 6. Okay, we have here 6. Multiply with this bond. Okay, the bond energy here, 4, 1, 2. Okay, what's the next? Next is we have the bonding. Okay, double bond. So C double bond, we have only one. All right, only one. Let me change the color here. Only one. So we have the 6, 1, 1. Now we have a single bonding of C and C, which is 3, 4, 8. Okay. So, and then not forgetting this one, now we have a bromine. Okay, bromine bonding. If you want to break it, you need 1, 9, 3. Okay, so this is under the category of you break the bond, you absorb heat, so it is called as endo. Now we total up all this. All right, we total up. Okay, let me calculate this. So you'll be getting here 6 times 412, 611, 348 and 193. So you'll be getting total here is about 3624 kilojoule. Okay, now here for forming the bond, so okay, let me change my color again. Okay, now we look at the C and H. CH bond 1, 2, 3, 4, 5 and 6. Still the same 6. Okay, and then we look at this single bonding of carbon to carbon. Okay, 1 and 2. So we have 2 there. So each of them is 3, 4 and 8. Now we look at carbon and bromine. So here, this part. So here we have 2. Carbon and bromine, we have 2. Each of them is 285. Okay, now we calculate the whole thing. So you'll be getting here about 3, 7, 3 and 8. This is kilojoule. Okay, let me scroll down. Okay, so this is the energy changes they are asking for. So your formula here will be endo, alright, endo minus with exo. So your endo here will be 3624 minus with exo 3738. So when we minus them, we will be getting here about negative 114 kilojoules. So we just put there negative 114. So it means the entire operation, the reaction here is exo. Okay, is exothermic. Okay, now okay, I hope you can understand this calculation, right? Okay, so it's almost out for every paper. Okay, now we look at the C. The boiling point of bromine is 59 and the boiling point of iodine is 184. Explain why iodine has higher boiling point than bromine. Okay, this is in the group of 17, right? So if you remember the group 17, we have fluorine, we have chlorine, bromine and also iodine. So iodine is lower than bromine where it has a additional shell. Okay, so you can say that iodine has additional shell and more particles in terms of protons, okay, protons and neutrons more than bromine. So what happens if you have more particles? You'll be having a stronger, iodine will be having a stronger attraction forces. Okay, stronger attractive force between these molecules. So when you're having a stronger forces between their molecules, obviously your boiling point will be higher. Okay, so this is the answer. This is for 2 marks and we have completed the second question. Total for the second question is 10 marks. Okay, now let us move to the next question. Okay, here number 3. Magnesium is a metal. Alright. So A. Describe the structure and bonding in magnesium. So here they are asking only about magnesium. So it is definitely is a metallic bonding. So let me scroll a little bit up higher to explain to you what is metallic bonding. So this is definitely is a metallic bonding. Okay, what is metallic bonding? Metallic bonding, just remember. So okay, inside a piece of aluminium, so we will have, okay, what's the ion of magnesium? remember all the ions from a metal must be a positive, okay, cation. So here we have magnesium 2 positive, magnesium 2 positive, I just write here 2 positive, okay, 2 positive, okay. Now and they are surrounded with electrons everywhere, okay. They have electrons everywhere around the positive ion. So they will have an attraction between a positive ion and also this negative ion. They will have a very strong attraction. So that's what makes the metal to have a very high boiling point. Okay, so this is basically is a melting metallic bonding. Okay, so let me write it down here. Okay, here, so you have a metallic bonding. Okay, regular arrangement of positive ion, okay, the cation, the magnesium 2 positive, and a sea of electrons, and they're having a strong attraction between positive ion and electrons. Okay, so this is your the answer for describe the structure and bonding in magnesium. Okay, so we are having a 3 marks. Okay, now let us scroll down. Okay, why can't magnesium conduct electricity when it is solid? Because your answer is very simple and you don't have no moving ions or electrons. Okay, so you can write it down here. Okay, and then this is my suggested answer here. Okay, when it is in solid, so what happens? You don't have a free electrons that will move and flow throughout the structure. So remember, when you have a metal, okay, if it is a metal and you can conduct electricity, it is all because you having a free ions, free moving electrons and ions, positive or negative, that are freely moving, okay, like electrolyte. So we need that. So if you don't have free electrons here, so you cannot conduct electricity. Okay, now the C here, why is magnesium is permeable? Okay, the meaning permeable means, it means the metal can be bent easily. Okay, you can bend in any way you like. So it is all because you have a layer of atoms or ion that you can slide together. Okay, so let me write it down. Okay, let me scroll down a bit. Okay, so it has a layer. It has a layer of atoms that can slide over each another without breaking the bonds. It means like you have like an arrangement of atoms or ion. This is the first layer. Okay, this first one, and we have another layer down here, another layer on top. So they can actually like slide in this way, and this layer will be going in this way. So they can actually slide, and it will make the metals much more easier to bend. So this is a structure of their atoms. Okay, so we move on with the next question. Okay, here the D. Magnesium reacts with sulfur to form ionic compound magnesium sulfate. Alright, so we have here magnesium 2 plus, it will donate 2 electrons, and we have a sulfur here is 2 negative. The diagram shows electronic structure of atom of magnesium and sulfur. So here we have 2, it will be donated. Okay, this 2 you will be donated 2 electrons. 2 electrons. So let me make a repair here. 2 electrons will be donated. So complete the diagram to show the electronic structure of ions in magnesium sulfate. So show the charge of the ions. So here will be 2 positive and here will be 2 negative because it receives. Okay, so these 2 will be gone. So you have to draw another shell that has electrons. So we have 8 here. 1, 2, 3, 4, 5, 6, 7, 8. And this electron this X, right? X, you have to put here another one. Let me draw it here, the next shell. Okay, so here will be 6 circle, 1 2 3 4 5 and 6, and here you have an X here, and X over here. That makes them 2 negative. Okay, so this is the suggested answer for this question. It's 3 marks. Okay, now we move on with the last one. So here we have last question for this. Ionic compounds such as magnesium sulfate do not conduct electricity when solid. Magnesium sulfate does not dissolve in water. It does conduct electricity under certain conditions. State the condition needed for magnesium sulfate to conduct electricity. Explain why magnesium sulfate conduct electricity under this condition. Okay, the condition is metals. Okay, magnesium sulfate or we just put the MgS. Okay, must be in molten form. Okay, this is your only choice because the magnesium sulfate does not dissolve in water, so it does not produce an aqueous solution. So it must be melted. Okay, must be in molten form. After melting it, to make them as electrolyte. Okay, this is due to, okay, this one is due to movable ion. Okay, or you can see it's a moving ion, moving due to the presence of, okay, due to the presence of moving ion. Okay, so this will be the answer for this. Is 2 marks, and you have here 12 marks. Okay, so this is for question number 3. So let us move to the question number 4. Okay, for number 4, gasoline is used as a fuel for cars. It is a mixture of hydrocarbon. Okay, you have a C and H only. Okay, name the raw material from which gasoline is obtained. So it should be your only one answer, which is a petroleum. Okay, petroleum. Okay, now one of the compound in gasoline is heptane. Okay, you have here heptane, so you have to follow this formula, right? So you'll be getting plus with 2. So you got C7 and H is 16. Heptane is a saturated hydrocarbon. Yes, it is a alkane group. Okay, what is mean by saturated hydrocarbon? So saturated means only single carbon available. You can write here only single bond. And there is no double bond. Okay, please remember that. No double bond. Okay, for hydrocarbon, you only contains carbon and hydrogen, or you can put it in a full carbon and also hydrogen. Okay, so that's your simplified answer for saturated and also hydrocarbon. Okay, to which homologous series does heptane belongs? So it belongs to alkane, A and E. Make sure it's not the E and E. Okay, alright, so we move on with the next one. Okay, give 2 characteristics of a homologous series. So number 1 is they will have a same functioning group. Functional group is like something like, if it is an alcohol, you have OH. If it's a carboxylic, you will have this. Okay, you will have this one. and you have if it is alkene, you have this double bond. So this is the functional group, and they will have a same general formula. And the formula for this is CnH2n plus 2. You just have to substitute with the n, the number of the carbon. Complete the chemical equation for complete combustion of heptane. Remember, you can have alcohol, you can have alkene, alkane. So once you come for complete combustion, you must have only carbon dioxide and water. That's all. If it is incomplete, then you can have a carbon, the soot we call it, okay, the black color gas, soot, and also you will also releases carbon monoxide. This is if incomplete. Okay, this is for incomplete. Now we have to balance this equation. So let me make it slightly bigger. Alright, so now here we have 7. Alright, so we can put here 7. To complete the equation, make sure the number of the elements here and here must be the same. Now carbon got 7, and here you have also 7. Now we look at oxygen. Oxygen, here you have 14. So 7 multiplied with 2, here got 14. And here, I'm not sure. Okay, so here you must have 16, right? So let us solve the hydrogen first. So hydrogen, here you have 16 atoms. So here we have to add on with 8. So you got 16 too. So hydrogen time, carbon time for both sides. Now we have to focus on oxygen. So oxygen, here we got 14, and from here we got 8. So all total we are getting here about 22 atoms. So here when we have 2, so we just have to put here 11. So oxygen here become 22 too. Okay, so let me reduce the size. Okay, so this is 2 marks. Okay, so let us move on with the next question. Okay, C. Car engine produces carbon monoxide, CO, and oxides of nitrogen. It can be this one. Okay, nitrogen dioxide. Okay, name the environmental problem that causes by the release of oxides of nitrogen into the air. So you will have acid rain. The most common answer for this type of questions. Okay, explain how carbon monoxide and oxides of nitrogen are formed in car engines. Okay, as I explained to you just now, it is formed due to, you can say, due to incomplete combustion. It means the combustion do not have enough oxygen. Okay, this is for the carbon monoxide. Okay, now how about the carbon oxides of nitrogen? Okay, so most probably the nitrogen, because nitrogen in the air, okay, now you can say nitrogen gas from air and oxygen from the air combines in the engine due to high temperature of the engine. Okay, it is also can be caused due to the spark, the engine spark. Okay, so this is the answer for 3 marks. Here's 1 mark and here's 2 marks. Okay, state one adverse effect of a carbon monoxide on human health. So this is more to biology. Adverse effect is the worst effect. so it can cause toxic and death. Okay, it's the worst effect, because it will reduce the transportation of oxygen in our red blood cell to the human body, and it can cause death. Okay, now let us scroll down. Okay, describe and explain how catalytic converter remove oxides of nitrogen from car engine exhaust fan. You are advised to include a chemical equation in your answer. And here we have 3 marks. Okay, now for the solution, there is 3 ways on how this catalytic converter could save our environment. So the first thing is, we have a nitrogen dioxide. Okay, so what it will do, when the gas enters a catalytic converter, it will convert into nitrogen gas plus with oxygen. Okay, so here's the equation here. Here's 2. So we can balance it. So we have these 2 gases is harmful. Okay, so it is in our atmosphere air. So this is, they change nitrogen dioxide to nitrogen gas and oxygen. Okay, this is the first one. The second one here will be carbon monoxide. So carbon monoxide will be further oxidized. Okay, will be further oxidized to form carbon dioxide. So it will be further oxidized to form carbon dioxide. So here we have 2 and C, here's 2, O is 4. So this is how we do this balancing. And the last one, because it's 3 ways, right? So there's the last one here, and we have oxidation of hydrocarbon. So hydrocarbon, let's say we just make it like okay, let's say for example we have a methane gas. It will be completely oxidized, okay, to form a carbon dioxide plus with water. Okay, so here we just have to balance this equation. Here we have to put 2, here's 2, here's 2, and we have oxygen 2 and 2, so we just put here 2. Okay, so this is the 3 equations. So it's oxidation of nitrogen dioxide, oxidation of carbon monoxide, and oxidation of a hydrocarbon. Okay, so this is the answer for number 3. Now let us move on. Okay, for the D, formula C4H10 represents 2 structural isomer. Isomer here, it means okay, there is a question here. What is meant by term structural isomers? Okay, so this is your answer. So structural isomer here means they have a same molecular formula. So both is C4 and H is 10, but their structure is different. So this is what is meant by isomers. Okay, now we go back to first question. Name isomer A. So we have here, this one should be under alkyne group. So it's we have 4 carbons, and here should be butane. Okay, so we move on. Next one. Okay, isomer B reacts with chlorine in a substitution reaction. Give the condition required for the reaction to occur and draw the structures of 2 possible products, one of which is organic and one of which is not organic. So the condition here for the substitution reaction, it must be exposed with a UV light. Okay, this must be exposed with UV light. So isomer B. So let us look at isomer B now. So we have CCC. Okay, let us draw it here. Okay. So we have this. Okay, so we have 1, 2, 3, and the others are hydrogen. Okay, so let me take some time to fill up this hydrogen, hydrogen, hydrogen. Okay, and then they will be combined with this chlorine atom. Alright, so when this one breaks, when it breaks apart, so this chlorine will be combined with this one. Okay, so it will substitute, it will replace. So at the end here you'll be having, okay, now let me draw it again, the same thing, C, C, C. Here you have a chlorine, hydrogen, hydrogen, and here's one more C, hydrogen, hydrogen, hydrogen. Okay, so you can notice here this part, it is being replaced. Okay, that's why the reaction is substitution reaction, they replace. So where does this hydrogen go? So this hydrogen will go and combine with another chlorine here, they'll combine. So you will have plus with the hydrochloric, and this one will continue until all the hydrogen being replaced with the chlorine. Okay, so this is the substitution reaction. So this is a structural product. So for this question 4, we have total about 23 marks. Okay, so let us move on with the next one. Okay, this is the next question, number 5. The diagram shows a simple cell. Here's voltmeter, here's metal 1, metal 2. Okay, when you have a different metal, then this is a voltaic cell. Okay, this is a voltaic cell. Or maybe something like a battery. It is not a electrolysis. So this is electrolyte. Okay. The simple cell was used with different metals as electrodes. The voltage were recorded in the table. Okay, so here just for your explanation, we will have like metal 1 and metal 2 in this electrochemical series, right? So the further the distance, the further the distance of both of these metal, you are getting the larger voltage. So your distance in electrochemical series is high, your voltage is higher also. Alright, so always remember this. So now let us go for, let me scroll down. Okay, now if the voltage measured is positive, then metal 2 is more reactive than metal 1. If the voltage measured is negative, then metal 1 is much more reactive than metal 2. Okay, so here we have a beryllium, cobalt, nickel, silver and vanadium, and same goes to here. Okay, now we have to rearrange in a electrochemical series. So the higher one will be the most reactive and the lower one should be the least reactive. Okay, so when you have a same metals will be 0. So beryllium and cobalt. So if the voltage is negative, metal 1 is more reactive than metal 2. So it means that beryllium is much more reactive than cobalt. So we just put here beryllium and cobalt. Okay, now we compare cobalt with nickel. Cobalt with nickel 0, and beryllium with nickel. So beryllium is much more reactive. You may already mention here. Okay, beryllium is much more reactive than nickel, but it's the same voltage with cobalt. Okay, so we look at the positive one. Positive one here will be metal 2 more reactive than metal 1. So vanadium should be higher reactive with cobalt. So here's vanadium. So here's vanadium on top with cobalt. So it should be here. It should be in between here, because beryllium with vanadium is showing negative. So it means beryllium should be higher reactivity. Okay, so this is number 1, and it is positive for all. So it means, okay, you can avoid this. Okay, because okay, so when it's a positive, the vanadium here should be higher reactivity with the others. Okay, now let us check with nickel and silver. It is showing negative. Okay, nickel and silver. Cobalt and silver. Okay, so should be silver and nickel. So when we compare vanadium and nickel, vanadium and silver, so silver should be the, so here I have to erase this. When you scroll down, so here this part I have to write nickel at first and silver lower. So silver is argentum, so I have to put here Ag. So okay, so this is your vanadium and silver. Beryllium and silver is not measured. Okay, so this is your possible list. Okay, your possible list of electrochemical series. Okay, define oxidation in terms of electron. So you can say in terms of electron is loss of electron. So you can say it is a loss of electron. Like example Mg2 plus with 2 electrons. So this is an oxidation because they lose electron. This is an example. Okay. So now let us move on with the next one. Okay. Nickel form ion with charge 2 positive. Nickel 2 positive is similar with magnesium. So we just have to write it down. Nickel 2 positive. It lost 2 electrons. Okay. What will happen to the mass of nickel electrode when nickel is oxidized? So it will get smaller. Okay, it will be the electrode will be smaller in size, or you can also say lower mass. Okay, lower mass. Okay, now we move on with the next question. Okay, use the data in the table to answer the following questions. Which of the metal in the table is most reactive? Most reactive, it means it must be at the on top. Okay, on top. Okay, as we have discussed just now, look at here. Vanadium is positive for all except for beryllium. It means beryllium is still the higher reactivity. Okay, higher reactivity. So okay, now for the second one, state which two different metals have the same reactivity. So same voltage is the same reactivity. Now we look. Okay, as you can see, we have the same voltage over here at this part. Okay, so which goes for cobalt and nickel. So these are the same in a same position. So now so you can write here is a cobalt and nickel. Okay, third one, predict the voltage produced by a simple cell with beryllium as metal 1 and silver as metal 2. So metal 1 and metal 2. So we go back to the question. Okay, so here metal, this is metal 1, metal 1, and this one is a metal 2. So vanadium, okay, let us check with vanadium and silver. From vanadium to silver is 2.0. Okay, it's a 2.0. So when you look at it, here should be around more than 2 and must be in negative. Okay, must be negative because this is a metal 1. So now we go back to here. It should be about negative 2.2 to negative 2.7. Okay, so it should be higher than 2. Then that's your answer for number 2. Okay, for 2 marks. Okay, now here last one, Describe how the simple cell in the diagram can be used to show that magnesium is more reactive than beryllium. Explain your answer. Okay, so we can explain in this way. We set up a magnesium and beryllium as electrodes. Magnesium as the metal 1 and the beryllium is as metal 2. So if magnesium should be more reactive, so now let us look at here. Not this one. Okay. So if metal 1 is more reactive, so you can say the voltage must appear to be a negative, right? So you can actually observe over here. Okay, if the voltage is measured as negative, metal 1 is more reactive than metal 2. So we can write it down here. A negative answer, negative voltage obtained. So this is your answer here. This is for 2 marks. So total for this question you'll be getting here about 10 marks. Okay. So let us move to the next question. Okay, number 6. Barium carbonate. Okay, barium carbonate is an insoluble solid. When barium carbonate heated strongly, it undergoes thermal decomposition. One of the products is a barium oxide. So write a chemical equation for the thermal decomposition of barium carbonate. So we can say in this way, barium carbonate will be barium oxide and they will release carbon dioxide. 1 mark here. Okay, suggest the pH of solution formed when barium oxide is added to water. Okay, barium oxide, anything to do with metal oxide or metal hydroxide, it should be more to alkaline. Okay, it's a strong alkaline. So you can expect a pH between 10 to pH 14. Alright, so just please remember this. If anything you have an oxide and hydroxide, it should be under alkaline. Okay. Barium nitride decomposed on heating in the same way as magnesium nitrate decomposes. Name 2 gas products formed when barium nitrate is heated. So here we will have nitrogen dioxide and also oxygen. Okay, so this is your, if a barium nitrate decomposed, you will have these 2 gases. Okay, so please remember this. Okay, next we are going to the next question here. Okay, an aqueous sodium carbonate is added to aqueous barium nitrate. Write chemical equation for the reaction of aqueous sodium carbonate with aqueous sodium barium nitrate. Okay, sodium carbonate Na2 carbonate plus with barium nitrate, but barium is 2 plus, so Na3, put a bracket here 2, and then they will exchange barium carbonate. 3 is quite far. Okay, so we just put here, it should be sodium nitrate. Okay, so this one is insoluble as they mentioned earlier, and this one nitrate salt is soluble, so you can actually obtain this. Okay, describe how a pure sample of barium carbonate could be obtained from the resulting mixture. So first of all, because this one is a soluble, so it means your final solution you will have a precipitate. Okay, you have a precipitate and you have this aqueous. So this one here will be barium carbonate, and the liquid here will be nitrate, sodium nitrate. So you just have to filter it because you need to obtain this. Okay, filter and wash the residue with water and then dry. So this is called as residue, the balance. Okay, so dry the residue. with filter paper. Okay, so this is for 3 marks, and we wait until it dry. You can actually cool it after that to form crystallization. Cool until crystallization is formed. Okay, so this is for 3 marks. So we move on with next question here. Okay, barium carbonate react with dilute hydrochloric acid. So this is the equation, and we have 9.85 gram of barium carbonate were added to 250 centimeter cube of 1 molarity of hydrochloric acid. This is excess. Okay, this is excess, so we don't have to include this in our calculation. How many mole of barium carbonate were used? So mass divided by RMM to get the mole is the formula. Okay, so 9.85 divided by barium, so Ba, so we know okay, carbon we have 12, oxygen is 16. Let us check on barium. All right, so we have to search for the barium. Okay, now look at here, the barium is 137. Look at here, barium is 137. Okay, so now we go back to the question. So barium is 137, so this is 137 plus with 12 plus with 48. It means 16 multiplied with 3, because we have the 3 oxygen there. So we add on all together, so we will be getting, this is 137 plus 12 plus 48. So you'll be getting here about 197. Okay, so this one will be divided by 197. This is will be equals with 0.05 mole. Okay, 0.05 mole. Deduce how many mole of carbon dioxide were made when all barium carbonate had reacted. Okay, we have to look at this ratio. Here's 1, here's 2, based on this 1, 1, 1. So you must have the same. Okay, you must have the same mole. So if here is 0.01, here should be 0.1. The rest of it must be 0.05. So it is also must be the same answer, 0.05. Okay, now we look at the next one. Calculate the volume of carbon dioxide formed in C2 at room temperature. Okay, if it is room temperature, it means it is a 24 dimetric cube. So what happened here? Mole times with 24 dimetric cube to get the volume. So 0.05 multiplied with 24, and you'll be getting here 1.2 dimetric cube. Okay, so the next one, okay, calculate how many mole of hydrochloric acid were in excess. So okay, now they only react, as I showed here just now. Okay, it only react about 0.1 mole. So now we have to calculate. We take this volume and the molarity. Okay, 250 and 1. So we will go back to here. So we can use this formula. MV divided by 1000. So here you got 1, and here's about 250. Divided with 1000, and here the mole that are in excess here will be about 250 divided with 1000. Here you are getting about 0.25. This is the mole Okay, this is the mole, but only used about 0.1 mole. So you have in excess 0.25 minus with 0.1. In excess here will be 0.15. So that is your mole in excess of hydrochloric acid. Okay, so this is 2 marks, and the total question here for the total marks for this question is 15 marks. So we have done this paper. So I have explained to you every question. So I hope you learned something new. I hope you enjoyed the video. So anything, just please give me the feedback in comment. Please like and subscribe. Okay, so thank you very much guys for watching.